Okay, welcome back. Now we're going to take a look at a multi-step problem with impulse. So we're going to do our 7-step process. We have a 1,500 kilogram car, which is a mass. It's traveling at 30 meters per second, which is a velocity. The driver of the car sees a child on the road and slams the brakes. The car stops in stops. That's a velocity, right? And we have a time, because the velocity here is 0, right? Question, what is the average force? What's the force? Sorry, that's an F. Force, question mark, exerted on the car during this stop. And then we're going to also answer what is the impulse. So we're just going to work step A to start with. So let's start with our picture. We have a mass equal 1,500 kilogram car. It is traveling at velocity equal 30 meters per second. And it comes to a stop, velocity equals 0. And it took it 3.2 seconds to stop. Force equals question mark. So I'm going to do my KUF. What are my knowns? Mass equals 1,500 kilograms. V1 equals 30. V2 equals 0. And my time equals 3.2 seconds. I do not know my acceleration. I also do not know the force. Okay? So we can do this problem, and there's actually another way to do this problem. We're going to do it this way first. So let's look at our equation sheet and let's find our acceleration. Acceleration equals delta V over delta T. So we have V2 minus V1 over our time, which is 3 point. Here, let me write it. Sorry, getting ahead of myself. Over time, which equals 30 minus 0 over 3.2. Okay. So hopefully you've gotten to this part. I'm actually going to, because of how I got my slide set up, I'm going to erase a little bit over here with this picture. Okay, so we have room. I'm going to erase a little bit with this picture. I just want you to know this right here, this area that we're going to be working in should go underneath down here, okay? But what's 30 divided by 3.2 equals, pull out a calculator, and what do you get? Let's see, 30 divide 3.2 equals 9.375 meters per second squared. That's our acceleration. And then now we have to find our force. Force equals mass times acceleration. So 1,500 times 9.375 equals, so times 1,500 equals 14,062.5 newtons. Okay? That's all for part A. We found our acceleration, and now we have our force. Okay? Now, let's look at part B. What is the impulse on the car? So we still are using the same picture from earlier, but now our KUF. What do we care about? We want the force, which we said was 14,062.5 newtons, and the time equals 3.2 seconds. Impulse equals question mark, and the force And the formula would be J equals force times delta T. Plug in our numbers. 14,062.5 times, I'm running out of room here, 3.2. Okay? 14,060, here, I'm going to rewrite that down here so you can see it. 14,062.5 times 3.2. Okay? So plug that in your calculator. Equals an impulse equal to 45,000 newtons times seconds. So that is the answer to part B. Okay? So that can get really confusing and complicated if you're not doing your KUF chart. Alright? So get that down, and now I'm going to show you a different way to do this same problem. Okay? It's actually by working it backwards. So let's go back, and now we have, let's go back to our KUF, the original. We have mass equal 1,500 kilograms. V1 equals 30 meters per second. V2 equals, what did we say, 0 meters per second. And time equal 3.2 seconds. Okay? If you use impulse equals the change in mass times velocity, is the mass changing in this? Is 1,500 changing at all? No, so 1,500 stays the same, but the velocity changes, so 30 minus 0, and we get 1,500 times 30, which is 45,000 newtons times seconds. That's our impulse. That's the answer to part B. And now I can take my impulse equals force times time, and I can say 45,000 equals force times 3.2 seconds, and I can divide both sides by 3.2. And you should get force equals 14,062.5 newtons. Okay? So same problem, two different ways to work it. You should be able to do it either way. Okay? All right. So you have 3 more problems on this that you need to go back and attempt on your own. You can try it either way. I prefer you try it both ways so that you can be familiar with both ways, because they each have different uses. All right, thank you.